So good afternoon, everyone. I am Chen Zhang from Central Researching Institute of United Imaging Group, and I also an independent developer, a software developer, and a researcher. And despite of different background, but today I will share some common things that always happen in scientific research, especially on the transition from experimental stage to the industrial usage. So, in my presentation, I would like to introduce my work in aspects of its background and motivation, and the framework and its two chains designed to address those practical issues and some applied instances and some work in progress. So, wait, 没声音。OK， 这个是不是没声音？喂，没声音，我直接这样说吧。好。Okay, we know with the development of AI technique and prototypical utilities proposed in service for different domain-specific application, the Python become a popular platform since its high efficiency in data processing and exchange. As a freely accessible programming language, the Python have developed a vibrant community and ecosystem in many study fields. However, in practical engineering, we find that it is not such easy to integrate multiple Python-based packages especially in the condition of interdisciplinary applications. So for building the Fluent pipeline among different study fields on basis of plenty of my refactoring work, and I have summarized the following 3 points, which is the most obstacle, I think, most of our work in the experimental stage rather than into the practical usage. The first one is the data protocol, because the data expression in different domains have its own expression. And for example, in structural mechanics, researchers may concern the spatial data points and calculate their relationship through such like PDE. In digital medicine, the researcher maybe struggle to calculate the dense matrix or tensor in desire to circle out the high-risky region. So the data in different study fields have its own expressions. So for systematic integration, the challenge comes from how we express them in a coherent format. And the second is the second one is the design mode of different package, because you can imagine that for a command line based package or an invocation based package, it all works very well in Python, but it is difficult to integrate each other because its underlying structure is totally different. So, and the last one is the coding style, because this is most challenging in Python, because the Python is very flexible, so the code style may be vary person to person, from person to person. So, and imagine if you are software architecture and your daily work is to track the bugs that raise from some ungranted functions from others, it's very difficult to go further. So So to address the aforementioned issues and simultaneously to satisfy the trade-off between the flexibility and the flexibility and the robustness, and we propose this framework. And this is, as for the design principles of our framework, we abstractly deem all the data processing, including the model training and the data mapping. The data manipulations are converted from one format to another. So, in this condition, we can abstract the data manipulation as the data and the corresponding operation parameters. So, with this design, we develop a lot of meta implementations to deal with different data structure. Researchers can use those functions like the Lego blocks to build their domain-specific pipelines. While for the engineer, since the pipelines are capable to have the data exchange protocol, it's also easy to be integrated for more complicated structure. So this is the primary work. So we just investigate the argument passing mechanism in Python. So the function one, for function one, it demonstrates the four typical the argument passing approaches in Python, through which the definition and the invocation of Python is very flexible, but however, it is ununified on data controlling. So on the data processing and the parameter controlling. So it is very important to have a unified format. So luckily, we find that all the invocation can be equivalent. Can be substituted like the function 2 and the user variable keyword to pass all the argument. So we can prove that for all Python theoretically for all Python function definition, it can be wrapped as using this style. So for convenience, here and after we call it info function. Here also I show a glance on the what the info function look like. In our framework, with the wrapping as the info function, you can apply the runtime check for on the data input and data output, and we can also set default values and desired types as flexibly. So this is I simply introduced our framework for developers. The orange background is functional scope. The blocks in different colors means the different two chains. So the green block are the in-place testing framework for Python function, which can facilitate the development in implementing of Python function. The gray utility is used for attaching the attribute and the set parameter configuration for that Python function. And with that parameter configuration, and we can use Navi1 to control the data input and output. So here it shows an example. This slide shows two typical applications use our framework. The first one is the input and like this. the input and output, data input and output control. With the invocation inside the decorator, you can use the class, use a typing hint system in Python, and even use this too, and to control the data, and if the data you accept or calculated is unmatched, what you desired, the error will raise. And the case, the example here is the second one in documentation. With its application, and it is unnecessary to integrate your function documentation code in the function body. So you can reorganize your code in some other script, and so you this will make your code look better. Okay. So in terms of argument configuration, the example above shows three typical ways to set default type for argument. You can use the class, the typing hint system in Python, and even the number function. And I will say the most interesting one is the last, is the third one, because it is very useful in mathematical computation, because sometimes we want to get the data or argument with some property, like the matrix with a symmetric one, or positive definite one, or semi-positive definite one. So you can just define that as a function, like this, and then use this function again as a constraint to make your to set as a type of your argument. So like this partial, it will make your API look more easy to understand. So and the last one is a testing framework. So in Python, maybe you scripting your function, and in the and you have to test your function in another place. So maybe you need to roll up and down repeatedly. So in this, with this framework, you can directly write your test case on the above the function. So it is very convenient to during your development. And also this is show an example for the unit test for the implemented functions. So, and for the next section, I will show you some its related applications. The content we mentioned above is actually the underlying structure of informatics project design for satisfying a lot of computing requirement. And this project is a very has a very comprehensive documentation system and detailed examples. The picture here show in this slide is their API for the math computation on dense tensor, it allows us to process the data in different dimensions via a unifying approach. So I will show, this is some examples through the mathematical computation. Like this here, the fingerprint augmentation on bioinformatics, and here is the nuclei recognition in pathology, and this is the this is a grain identification recognition on material research, and the last one is some semantic classification on topography. And this is also some other examples to integrate the technicals in CV and in pattern recognition in immunology. And the last one is the example for further statistical modeling on the previous example. And besides this, informatics project also affords the researchers some handy tools to do the data visualization. This is a basic line, scatter, histogram, or such like. And also for the 3D three-dimensional data, three-dimensional tensor, it also has its image viewer to do the rendering. And this is a case study in radiology. So this is some works in progress I do to. Actually, it has been implemented, but I'm working on documenting this part of work to generalize some implementation. So you can see the data is two-dimensional or three-dimensional despite a different data structure, and use the generic function, we can get the coherent result. So to summary, I will show you a very interesting things. Just not the Python syntax use the informatics project that don't like the traditional Python. You can see that this part, this is, you can see it's a wrapper, and you use this as a wrapper from the common traditional Python function to the info function. And for info function, they can connect just like function communicate with each other. Just use crop, denoising, and resampling. I first built the pre-processing pipeline on the for the natural image or for three-dimensional image. That's okay. And this implemented pipeline is also can be easily to reuse, like the last line showed. Use in the if we want to compare the result after this pre-processing and to followed with three different each augmentation, just use like this. So if you have more interest interesting about this, you can find this project has been merged in the Python package index here, and you just search the informatics, and you can find some detail and its corresponding documentations. Okay, that's all.